Hello, so today we are going to do problems from weekly contest 337, this week's weekly contest. The second problem, check night tour configuration. So basically what this problem says is we have a knight on an n by n chessboard, and the valid configuration, basically the knight starts from the top left cell, so this one, and then visits every cell on the board exactly once. Okay, not necessarily like in the order, the usual order where you go like either something like this, like that. The order is a little bit different here, but it always starts from the top left. And the numbers, these cells have numbers, right? So for example, in the second example here, you can see the top left one have 0, the one way down here have 1, and then another one, 2 is way down here, 3 is here. You get the idea. Now, the numbers are from 0 to n by multiplied by n minus 1. So n being the number of rows and the number of columns. This is n by n chessboard. And basically the grid, the value in the cell indicates that cell on row column is the grid row. The value in the cell, it's the x. If the value in the cell is x, it's the xth cell that we visited. What do we mean by that? So basically this means that, for example, 3 here, this means that this is the third cell we visited, starting from 0. So 0 is the first one. Then 1 here, let's call this the 0th cell because it's the starting cell. 1 is the first cell we visit from 0. 2 is the second cell we visit. 3 is the third cell we visit. 4 is the fourth cell we visit. So that the number basically tells us the order we visited the cell at, right? And what we want to do is return true if the configuration that we get is a valid configuration of the knight's movements, right? Now, how do we, what does valid mean here? That's what this note says. So basically a valid move is if you move 2 squares vertically and 1 horizontally, or 2 squares horizontally and 1 vertically. What does that mean? So basically it means the directions we have here. So for example, this one you can move up 2 cells, so 2 vertically and then 1 horizontally, so that gets you here. Or you could move 2 horizontally and then 1 vertically, and vertically can be either up like this or down like here. Okay, and similarly for 2 vertically and then 1 horizontally, it can be either up or down. So those are, and overall you have only 8 directions, right? You could go like that, you could go like this, you could go like this, you could go like that, you could go like this, or like that, and you get the idea. And overall you have, if you do them manually, you can see you have 8 moves. And the main idea is that 2 in one direction and then 1 in the other direction. So 2 vertically, 1 horizontally, or 2 horizontally and 1 vertically. So that's the definition of a valid move. And so let's take a look, for example, at this first example here where it returns that it's a valid configuration. How does that work? So for 0 to go from 1, we move 2 down and then 1 to the right. So that's a valid move. And then from 1 to 2, we move 2 down and then 1 to the right. That's a valid move as well. Same thing here, 2 down and then 1 to the right. From 2, we move 2 to the left horizontally and then 1 vertically up, right? And then from 3, we move 1 to the right and then 2 up. So 1 horizontally, 2 vertically. And if you continue and do it for all of them up until you get to the last position, which is 24, you will find that it does work. All of them are valid. So we return true for this case, right? Now for this second example, it's not valid because, for example, here you go from 0 to 1 like this. This is valid. From 1 to 2, 1 horizontally and then 1 vertically, 2 horizontally. So this one is valid. 2 to 3, this one is valid. 3 to 4 is valid. 4 to 5 is valid. 5 to 6 is valid. Right? Let's continue again. 6 to 7 is valid. 7 to 8 is not valid, right? Because it's just one step. So we return false. So that's roughly the idea of the problem. Now, how do we tackle it? Okay, so how do we tackle this problem? Well, what we know we want is that we want to have 0 to n by n minus 1 be adjacent. So basically going from 0 to 1 needs to be an adjacent cell, and the definition of adjacent is either basically 2 horizontally and 2 vertically, right? And 1 vertically, sorry, or 2 vertically and 1 horizontally. That's the definition of adjacent. And then from 1 to 2, same thing, it needs to be adjacent. Needs to be adjacent all the way until n by n minus 1, where from the previous one needs to be adjacent, right? If we encounter any one of these where it's not adjacent, we want to return that return false, because that means there was an invalid move, right? And so the way we can do this, instead of actually going through the grid and checking every move, what we can do is just go for x, take x from 0 to n by n minus 1, or from 1 to n by n minus 1, right? And just make sure that the cell that is that has the value x, right, is adjacent to the cell that had the value x minus 1, right? So basically, we want to just make sure that cell at x is adjacent to the previous cell at x minus 1, right? So to determine if it's adjacent, we need the coordinates, right? And so definitely we can keep coordinates of the previous one in ij. Initially they are 0, so this would be the coordinate of the previous cell. But how do we determine the coordinate of x value, right? What we can do is actually just pre-compute it, right? So basically just create an initial map where we can pre-compute it. So how do we do that? Well, we can just have some sort of a map of values, and initially we go through the grid, right? We go through every cell in the grid, basically by taking I from 0 to n, and j from 0 to n. And then we can just say the value at grid at ij, right, is going to be equal to just the coordinates, right, ij. Basically that way, with this here, to get the coordinates of cell x, we can just use that initial, we can just use this map where we can just say values of x will give us the coordinates, right? And this will give us the coordinates of the neighbor, which is the current cell, right? And now we can check if it's adjacent to the previous cell, and then so basically just check if adjacent. If not adjacent to the previous cell, we can return false. So if it's adjacent, basically if I and j, which is the previous cell, is adjacent to n I and j, if that's the case, then we are good. But if it's not, we can immediately return false, because this means x minus 1 was not adjacent to x, which means we did an invalid move, right? And so what should we do here? Well, we should just update the previous cell coordinates, so that for the next iteration for x plus 1, we use the previous one for x, right? So that for when we are looking at x plus 1, we use the coordinates of x. The coordinates of x are this, so we just need to update I and j, right? Okay. Now the only thing remaining for us, knowing this now, is how do we determine this adjacent? Well, the problem says it's adjacent if it's either 2 vertically and 1 horizontally, or 1 vertically and 2 horizontally, right? And it can be in different directions, either like that, like this, like this, like this, or like this, like that, like this, like this. But as long as it needs to be, the simplification of it needs to be 2 vertically and 1 horizontally, or 1 vertically and 2 horizontally. So this basically means that to check if n I and j is adjacent to I and j, we can just check the difference vertically and the difference horizontally and make sure it's one of these two cases, right? And so to do that, well, let's just have the difference horizontally. Let's call it dh. And it's going to be just the difference between, the absolute difference between the I indices, right? And then we can get the difference vertically, which is going to be the absolute value between j and nj. Okay, and now what we need to do is just check if this is one of these two cases. So we can just check if it's the first case, then we need dv to be equal to 2 and dh to be equal to 1. Or it's the second case, which is we need the difference vertically is 1 and the difference horizontally is 2. If it's any of these cases, we can return true. We can say that they are adjacent. If it's not, we can say that they are not adjacent and we can return false. And this simplifies the logic. Instead of like doing the other way to do it is to say I plus 2, j plus 1, I plus 2, j minus 1, I minus 2, j plus 1, and to go over all the combinations and list them out. Instead of doing that, we can just use the difference rule and just check. And this makes it a lot simpler to implement. And pretty much that's the whole idea here. The main idea is to actually go through the moves we need and just make sure each x to the next x plus 1 we do a valid move. And the way we do that, we just to check to get the coordinates easily for x is just we pre-compute so that we have a map from the values of x or the values of the cell to their coordinates. And that's pretty much it. This should solve it. So let's implement it and make sure it passes test cases. Okay, so now let's implement what we just saw. So first we need just the length of the grid. It's an n by n grid, so this would be the number of rows and the number of columns. And now we need the values, which basically will contain the cell value to coordinates, right? So you can think of it as basically value to ij pair, okay? So that's what this is. And now to calculate it, well, we just need to go through all the coordinates for the grid. And then we just say that the values for grid ij is going to be ij. You could also name it coordinates if you prefer, or value to coordinates. Okay, so now we go through x in the order from 1 to n by n. So this will stop at n by n minus 1, just the way Python works. Now, what is the previous cell for value 1? Well, it's the first initial cell, which is the top left one, which is at 0, 0. And now we can just, so this will actually test the move from 0 to 1, from value 0 to value 1. So how do we get the neighbor? How do we get the coordinates of x? Well, remember, we just have them here. So we just do value of x, that will give us the neighbors. Now we want to check if x minus 1 is adjacent to x, right? Which basically means check if ij is adjacent to nij. Okay, and so how do we do that? We said we use the difference horizontally and the difference vertically. The difference horizontally is just the absolute value of the difference between the horizontal indices, which is I and ni, and the vertical one is the difference between the vertical indices, which is j and nj. And now we can just check if it's one of the two cases that we said. So it's dh is equal to 2, or vertically it's 1. And so we move it 2 horizontally and 1 vertically, or the reverse, we move it 2 vertically and 1 horizontally. If it's one of these, we are good. So we just need the previous cell now to be marked to the current one. But if not, that means this was from x minus 1 to x was an invalid move. So we want to return false. At the end, if we went through all of the values of x and we didn't find any invalid move, we want to return true. Okay? And that should be it. So let's just run this. Let's submit. And looks good, it passes. Now, what about the time complexity here? We are doing, of course, this one, which is n by n, so n squared, the first loop. And this one here is also n squared because we go from 1 to n squared. So overall, time complexity is O of n squared. Now what about the space complexity? We are using these values, which also is n by n, right? Because it contains all the cell values. So it's n squared. And that's the only one we are using. So we are also O of n squared space. Okay. And this should be fine with the input, right? Because n is between 3 and 7. Okay. Yeah, so that's pretty much it for this problem. Please like and subscribe and see you on the next one. Bye.